All right, let's understand authentication, JWTs, and something called try catch. This is slightly off topic. High level, the video is going to be about how to do authentication in the real world using real world examples. Let me introduce you to Mishra ji. He's the manager of SBI Bank, basically the person who can open accounts in a bank. And this is Kirat from college, who's wanting to open a bank account in SBI. What is the usual flow if you want to open a bank account? You go to the bank, Kirat goes to open a bank account, Kirat deposits in some money, and Kirat gets back a checkbook from the bank. This checkbook part is interesting. This is a slightly India specific concept. Okay, you get back a book where you can put someone's name and amount and sign that specific page, which is called a check, that you then deposit to the bank, or the other party deposits to the bank to get back real money into their account or cash in their hand. This third part is important. Why do you get back a checkbook from the bank? So that the bank is like, you have opened an account, you have put in some money, you get back a checkbook, just sign this checkbook, give this check to whoever you want, and then they'll be able to withdraw money from your account. This checkbook is like an authenticated way कि भैया we have given you this, make sure you keep this safe. If you lose this, if this reaches the wrong hands, then your money is gone. There is some nuance here. You actually have to sign every check, but assume you don't have to sign checks. You are literally given a bunch of checks कि भैया these are your checks, keep them safe. If you lose them, then you're pretty much screwed. Your money is gone. ठीक है? Whenever I have to pay someone, I sign the check. Right here, I put an amount, I put their name. Everyone can see my signature. Have you noticed this? Have you ever felt like this is weird? Okay, if you have a checkbook and a check like this, you put someone's name, you put a signature, everyone can look at your signature. Everyone can look at what this specific check looks like. Have you ever felt weird? Okay, if everyone can see it, can't they just replicate it? Can they not create another piece of paper that looks exactly like this and, replicate my signature? Why is the signature so open? People can try to do the same sign at their checkbook, or people can, try to copy your complete checkbook, because as I said, it's like sort of an open paper. But banks won't accept theirs. They will only accept your check. Have you ever thought why this has happened? This is very closely related to JWTs. But my checkbook is equal to my JSON web tokens. This whole example that I shared here is actually how authentication works in the real world. Okay, if there is ever a backend, let's say ChatGPT, and you try to not open a bank account here, or you just sign in, which basically means you send your username and your password, which is similar to Kirat going to a bank and opening a bank account, asking for their checkbook. This getting back of the checkbook is the same as this getting back of JWT from the server. Why is this cool? Because now that you have this JWT, you can hit ChatGPT with any request. You can hit ChatGPT with a prompt, what is 2 plus 2, and you can send along this JWT. The point of this JWT is that bhaiya, you have been given this. Now whoever has access to this has access to your ChatGPT resources. So make sure you keep this very safe. Similarly, someone gives you a checkbook, you keep it very safe. You don't share it with anyone. You don't just give it to anyone. People can look at it, but generally even like looking at it is, borderline unsafe. You shouldn't do it. High level, both are doing the same things. Ki haan, this JWT and this checkbook, if you ever send back to the bank or to the backend server can use this JWT to verify it is you. And similarly, the bank server, if you ever go back to the bank with a check, the bank uses this check to verify that, this is Harkirat, and he has written he wants to send someone else 200 rupees. So let me approve this transfer. Okay? All right. The check is something the bank gives me the first time I visit it, which is similar to me signing in. Something I need to keep safe. If I lose the check, anyone can debit my account. Again, there is some nuance here. This check needs to be signed. But assume when you get back checks from the bank, you immediately sign them. Okay? If that happens, you will keep your checks very safe. Even though other people can see my signature, / how my checkbook looks, if they try to recreate it, the bank will catch them. You can't just look at someone's checkbook, try to recreate that piece of paper and sign. The bank will catch you and not let you debit their funds. If you look at it from a high level, visually it looks like this. You have the checkbook, and even though he can look at it, you can use the checkbook to, do whatever you want. This is the right checkbook. If the other person, even if they try to copy it and they try to send it, the bank will not let them debit their funds. But if you give them their exact signed checkbook, your exact signed checkbook, then they can steal your funds. If you literally tell them, take my checkbook and here is my signature and put your name here, then they can take your check to the bank and the intruder can actually debit your account. So what is the high level thing to learn through these examples? It is that this checkbook is something you need to keep safe. And even though other people can look at your checkbook, you never give it away to anyone. If you give it away, they can debit your funds. Similarly, whenever you're signing up on ChatGPT, the JWT that you get back, you keep it safe with you. You don't share it with anyone. JSON web tokens are just like these checkbooks. They are issued by the backend when you sign in. Anyone can create something very similar, but the backend would reject it, even though the JWT that you get back can somehow be recreated. We will see it, how that happens. But the backend will reject it. Unless you get the exact same one. If you lose the original JWT, if you lose the original checkbook, which is what's happening in this visual, then of course you're screwed. But if someone looks at yours and tries to replicate it, then you're not screwed. They can try to replicate it. The bank will reject it. Cool. That's a high level. Let's look at the same thing for ChatGPT. You hit the ChatGPT with your email and password. ChatGPT responds back with a JSON web token. This is basically the email password, some combination converted into a string. This is like the checkbook. Now, any request that you're sending, for example, if you write a prompt here, what is 2 + 2? Along with your prompt, you will send the JWT in the header. The backend will first verify this JWT. And only if it knows that this is the original Harkita JWT, the one that I gave back here, will it run the model and return you the value. Cool. This is how authentication works in the real world. This is one very prominent good way to do authentication. Let's start to look at the assignment for this week and see what exactly I introduced there. High level, there are 3 things we need to do, or 3 things we need to understand when you're creating these JWTs. Number 1, generating a JWT. Number 2, decoding a JWT. Number 3, verifying a JWT. There are slight nuances to these 3. Let's understand what all 3 of these do. Number 1, generating the JWT. Whenever you have a backend server, or in the real world, if you have a bank, generating means the bank actually issuing the checkbook, creating the checkbook, and bank having some machine through which it generates it. So it knows whenever it comes back, it can verify it. It somehow is printing something on this issued checkbook. I can figure out a fake from a real one. Similarly, backend server, when it generates, it just creates a very long string, which is just called the JWT, which if it ever comes back to the backend server, it can verify it. There is a big difference between decoding and verifying. If you understand this, you understand JWTs. Generate, simple. Verify, number 3. Let's put decode first. Decode, verify. What does decoding mean? If you ever have a checkbook, someone else can look at it and generate their own, which means other people can decode it. Other people can look at it and be like, acha, this is what it looks like. Very nice. Some text here, this signature here. I will copy. Someone else can look at it and decode and try to get very close to creating the original checkbook. But what is verification? Someone else cannot verify it. only the backend server which has that machine using which it generated the JWT, can it verify कि हाँ this JWT plus my machine that I have tell me कि हाँ this is correct or not. So what is the high level difference between decoding a JWT and verifying a JWT? Inputs to both of them are the same, which is a string. But the output here is कि हाँ this can only be done by the backend server which has the checkbook on the side, or checkbook generator. The checkbook generator machine, the machine that actually generated the original thing, can verify the JWT, but decoding anyone can do. Let's look at this more practically. Let's go to Replit and let's look at a simple example using JWT. The library we are using for it is called JSON Web Token. You can look at it on npm and it will show you that this is a library that lets you generate and verify and decode JWTs. Cool. 3 functions we need to understand: decode, verify, and generate. Let's start with generate. Let's do a simple JWT generation. Const value equal to name Harkirat, account number 123. Let's say a new SBI account has been created for me, and these are the details. I can create a token from this or a JWT from this. How? Const token equal to JWT dot generate the value that I want to encode and a password I want to encode with. This is similar to the checkbook generator I was talking about. This secret is what the bank has and only the bank has. And since this token has been generated using this secret, and hence this token can only be verified using this secret. This is the checkbook that the bank has, a checkbook generator that the bank has. If the bank ever loses this, then there is a problem. Then anyone can, verify checkbooks, which basically means they can, recreate checkbooks by, using that machine. For that reason, the bank should keep this very safe. And this is the holy grail of what protects a token. Let's log it. You will see it's like a very long string that gets printed. After this happens, taking a while. Generate is an error. Let's see, what's the error? Not a function. JWT is equal to require. Let's look at the npm docs again. JSON Web Token. And how do you import it? Const JWT require JSON Web Token. Looks right. Generate is not a function. Maybe it isn't. What is the function? It is sign. Okay, so it's not, the function to generate is sign. Basically, the process of creating the token. The function to call is sign and not generate. All right. What is generated or what is created finally? This very long thing. This is your checkbook. If you lose this, you've pretty much lost access to your account, or anyone else can access your funds or your account. This long string is like the checkbook. And as I said, anyone can look at your checkbook and try to recreate it. What did I mean by that? Basically, this thing that has been generated can be decoded by anyone without this secret. No one needs, if you give this to someone, they can actually decode and look at what the original contents were. We have just what's called encoded this. And encoding basically means that anyone can decode it without the secret. How do I do that? If I go to jwt.io, I can paste this string that I got And what does it say? Name Harkirat account number 123123. Notice I did not have to give it my secret. This secret that I've defined here, which could be anything random, I did not give it to this website. I just gave it this, and it is able to decode the original account number and name or the contents. This is the same thing as someone being able to look at your checkbook and being like, I can see your sign, I can see your checkbook, I can recreate it. This person can now, recreate a token, be like, acha, this was the contents, I will create my own token. And then this person can go to their own replit and, create a new REPL and be like, theek hai bhai, I see this, I'm going to recreate my own thing. But will that work? This person does not know. Let's say this is the intruder. They're like, I know the contents. I'm going to create my own token. Const new token equal to JWT dot sign the contents, and then some. Now the only thing that the intruder doesn't know is the bank's secret. The intruder doesn't know how the bank generates the checkbook. They can guess it, but most probably they'll be wrong. So this is the difference. Remove this. This is the difference. This is, anyone can look at your checkbook and try to recreate it, but unless they have the same checkbook generator as the bank, they won't succeed. And what is the checkbook generator here? It is this secret. Okay. So high level, always the thing to keep in mind is so see, this specific intruder said, yes, I have a string that decodes to the same thing as the original thing. But if you take this to the original server will be like, I cannot verify this. Let's take this intruder, this thing, and try to see if we can verify it here on this server with this secret. So verify this string right here, secret, let's run it. And as you can see, it says invalid signature. Isn't that what a bank official would tell you if you try to replicate someone's signature? Same thing is happening. If an intruder, even though the intruder is putting the same contents, creating their own JWT, since their secret is different, whatever the contents inside the JWT might be, this bank server will reject it. But if I try to do the same thing with the token that was generated on this server using this secret, verify, then you will notice no exception is thrown and it gets verified value. If I run it, you can see the contents of the verified value here. So what does this teach us? It teaches us that JWT are a little weird. Anyone can see the contents of a JWT given the original thing without the secret that was used to sign it. But only the server that signed it can verify it. If you try to create another variation of it, the server will reject it. Cool. Let's try to look at the assignment and implement a few of these functions. Look at some test cases and see how they actually show you the difference between decode and verify, which is basically the biggest thing to learn here. Before we proceed to the assignment, let's understand something called try catch. It will be useful in the assignment. And what are errors? What do I mean when I say throwing errors and catching errors in JavaScript? Let's begin with a simple function. You've been given a function called getLength, which takes a name as an input, returns the length of the number of letters in that specific string. For example, const answer equal to getLength of Harkirat, console.log answer, and this will log whatever is the length of this specific string, which in this case is 1, 2, 3, 4, 5, 6, 7, 8. That's what you see as the log here. Great, simple code base that works. Now, let's say I'm a dumb developer and I send the wrong input here. I forget to send anything here. What happens? Const answer equal to getLength. Control reaches here. It tries to access undefined.length. What is name if I don't pass in anything? It is undefined. What is undefined? It's just another type in JavaScript. If you go to replit, let's say I go here. If I do a const, let a and try to log it, you will see it prints undefined on the screen. which is just another type in JavaScript. And if I try to do a dot length, what do you think will happen? What is undefined dot length, or what is even, 2 dot length? It's not defined. It's not a function for an integer, and it's not a function on undefined, or an attribute on undefined. So something happens here. It what's called is throws an error. What does it do? It throws an error and stops execution right away. What do I mean when I say stops execution right away? It basically mean if I add another statement here, and if I run it, you will see, okay, this hi there never gets logged because the program doesn't know what to do after this. It panics here, it throws an error, and it stops executing. This is sort of bad. Developers are dumb. They make mistakes like these. They might write code like this, but that shouldn't stop, the code that's after from running. You should be able to catch these errors. That is where try catch comes into the picture. Let's look at this example again. If you run it, you will see a big exception here. This is what's called an exception. Control will never reach after it. When an exception is raised, the process exits since the JavaScript program doesn't want to proceed anymore. It's like, bro, I am done. Something broke here. This will not get logged. Hi there will not get logged. Control never reaches here. But you might want the program to still continue. That is where you can use try catches. So you might want, bhaiya, I want, even if there's an exception here, that is fine. Don't log anything. You don't know answer. Don't log answer. That's fine. But let the program proceed. Let it do the other things afterwards. Here you can use the try catch syntax, and it looks something like this. Let me write it in Replit first, and we'll come here. If you know there is a certain code base that is unsafe, which means that may throw an error, you wrap it inside a try catch. A good question to ask at this point might be, Kirat, how do I know if a code base is going to throw an error or not? If I knew it, I wouldn't write a dumb code like this, right? If I've written this dumb code, I don't know upfront that this can throw an error. Good. Yes, you are right, sir. You are a good question. And the answer here is, of course, you cannot catch all errors. If you write great code always, you don't even need try catch. But a bunch of times, something will throw an error. We will see such an example very soon when we use the JWT.verify function. JWT.verify actually either gives you back a value or throws an error, which is why when this function is going to do one of two things, you will try to wrap it inside a try catch. But we'll get there when we get there. Until then, what have I done? This code segment I put inside two braces and wrote try here. And after all of this, I wrote catch E and then curly braces here as well. This syntax that you see is called the try catch syntax. And the goal is, if there's ever an exception here, the control will stop executing. For example, if I put a console.log hi there from inside, the exception happens on this line because a.length does not exist. Control will not reach here, but it will stop executing inside these braces. The control will reach the catch statement. If I put a log here inside catch statement, control will reach inside the catch statement. It means if an error is caught, control reaches here. If this code is correct, control will never reach here. If there is an exception on any line here, control will reach here. And then, of course, everything else will proceed either way. What is the benefit of adding a try catch? You 100% know bhaiya, this code is going to run. If there is an exception here, that is fine. Control will reach here and then reach here. If there is no exception here, that is fine. Control will reach here, here, and then reach here. In no case will you see this does not get run because you have safeguarded your code. You have put it inside a try catch. If I run it, you will see it says inside the catch statement. So control reaches here, exception is thrown and control reaches here. It does not reach line number 5. Control reaches here and then control reaches here. This is what the try catch syntax is. Where is it used? It is used when you know a certain code base can throw an error. You wrap it inside a try catch. Cool. Let's look at the slides. What do they say? If no exception occurs, then it proceeds to line 12. If no exception occurs in these two lines, it will proceed normally to line 12. If an exception occurs, then the control reaches the catch statement here and then reaches the line 12. So normal execution proceeds either way. Either this whole will run and then this will run, or this will run partially catch will run and then this will run. But this code base will always run. That is the benefit of wrapping this sort of unsafe code. By unsafe, I mean something that can throw an exception inside curly braces. Cool. Assignment. Ab karte hain. Let's get into the assignment for this week. I would urge you to clone the repo locally, open it in VS Code. We have done it a few times now. In your folder, go to O2-JWT. If you don't understand these commands, then there is a problem. You haven't done bash yet. But if you clone it the first time, you will be in this assignments folder. You will have to go to CD week 3/O2JWT. If you are in a different folder, you eventually have to navigate to O2-JWT and run this command called npm install. Once you do, you should look at the readme for this second section. So go to this readme.md and try to read what the assignment says. It says, write a function that takes in a username and password and returns a JWT token with the username encoded. Should return null if the username is not a valid email or if the password is less than 6 characters. Try using the Zord library here. Cool. So it basically is a combination of not just JWT, but JWT and Zord. We have done Zord a little bit, so we will try to incorporate that in our solution. Cool. The first one, this is the function that it asks us to make. Returns encoded, correct. Let's try to implement this function. Username and password came. What does it want us to encode? It wants us to encode just the username. So what will it be? It will be JWT dot sign username and the global JWT password that they have already given us. It'll either be this username or it will be most probably this username inside curly braces. This is not very well defined here, or is it? With the username encoded. Yeah. It'll be this. It'll be inside curly braces. Should have been written here. Coded inside an object. This should be the original problem statement. So JWT.sign this thing. Const signature equal to this. Oh, shit easy. And then return signature. This is almost all you need. But there were two more problem statements. The username needs to be a valid email. For that, you can use the Zord library. Zord equal to require Zord. And then you can be like const email schema equal to Zord.string.email. Const password schema equal to Zord.string.min6. Okay, minimum it should have 6 letters is what I think. Password less than 6 characters, correct. So I have defined these Zord schemas. If you don't understand them, you have to go back to the video where we discussed Zord. Now that I have these, I have to check, okay, does username follow the email schema? So how do you do that? Const response or username response equal to email schema dot parse or safe parse actually. Username. And the second thing can be const password response equal to password schema dot safe parse password. Now that you have username response and password response, what did the statement say? If the password is less than 6 characters, should return null if username is not a valid email or if password is less than 6 characters. So you can be like, if not username response dot success or not password response dot success, which means if either this failed or this failed, then what will you return? Null. But if neither of them failed, then what will you return? The signature. Cool. That's a high level of how I would solve the first part here. Let's see if there are some tests for this. I think there's just one test file, so we'll have to do all 3 of these and only then we'll be able to test. But I can just copy this over to Replit and test it for a few of my own test cases. So let me paste this here and looks good. Let me call it with an incorrect email but a correct password. This is not valid email. So this should return null. Let me store this in an answer and log it. If I run it, it will now probably install a few libraries, Zod and JSON Web Token. Once it does it, it will run this function and I hope it returns null. It does return null. Looks right. If I make it a correct email, then it returns a signature. If I make this less than 60 characters, then it returns null. So seems like our Zod logic is working correctly and our signature is also happening correctly. We're returning the signature. First one is done. Let's look at the problem statement for the second one. What does it say? Write a function that takes a JWT as an input and returns true if the JWT can be decoded, not verified. Returns false otherwise. So what is this one need to supposed to do? This one probably decode JWT. It needs to return either true or false if the JWT can be decoded. So basically, what do I have to call? I have to call const decoded equal to JWT dot decode token. So this is a function that you get on the original JWT library. And notice it doesn't need any secret. This decoding is the same as me going to this jwt.io and pasting a token here. I can decode it without using the secret. And if there is an error here, for example, if I put some erroneous string here, then it will say invalid signature. And similarly, if there is an error here, then either this will throw an error or it will return null. It will probably just return null. So I can just simply be like, if decoded, then return true, else return false. This should be enough for this decode JWT function. Again, the thing to keep in mind is whatever the token might be, it can be decoded irrespective of the secret. If I copy this over, paste it on replit, and then call it with a incorrect JWT. How do I know this is an incorrect JWT? Because JWT follows a format which this does not follow that format. So for sure this will throw an error. And one thing I have to do at the top is const JWT equal to require JSON Web Token. If I run this, it says false. Sounds good. If I run this with a valid JWT, which I have just picked from this website, it returns true. So seems like decode JWT works as expected. Again, I picked a random JWT. I don't know what the secret for this is, but I'm still able to decode it similar to how this website is able to decode it. Now let's look at the third one. What does it say? All right, let's look at the third one. What does it say? It says, write a function that takes a JWT as an input and returns true if the JWT can be verified, not decoded, but verified. Return false otherwise. All right, let's go to the code base. Let's look at the verify JWT function. What is the first thing I need to do? Const decoded equal to JWT dot not decoded. Yeah, decoded dot verify. So this variable is usually called decoded. You can call it verified as well, whatever you want to call it. JWT dot verify the token and the password from the top. Now, if verified, then return true. Else return false. You might think this code base is enough, but there is one small problem here. If I copy this over to Replit, I don't have Replit right now. Let me run it locally. Let me create a new file here. Call it verify.js, and let me paste the code here and import JWT at the top. Let me try to run this specific file. If I go to O2 JWT, 3 O2 JWT node verify.js. Let me also, I need to add the JWT password. Let me pass in a token, verify JWT. Let me pass in an incorrect token. If I log this, again, you can log it like this, or you can be like const answer equal to this, and then console.log answer. If I now run this, you will see an exception is thrown. JWT malformed. Unfortunately, verify is a weird function. It's different from decode. What was the decode function? Okay, bhaiya, I will return you either null or I will return you the decoded string. But verify is like, bhai, I will either return you the verified string if this is correct, but if this token is incorrect, I will panic. I will throw an exception. And for that reason, I will, if you want to return either true or false, you need to wrap this inside a try catch. Okay, bhaiya, I will first verify. If everything works fine, sahi hai, return true. I actually don't even need the verified value, right? This function needs to return either true or false. It does not care about what the decoded value is. So I can simply do this. Okay, bhaiya, jwt.verify. There you go. If this does not throw an exception, this function will simply return here. Harkirat, you said if try catch mein to hamisha the control will reach here. That is not necessarily true. If you return, then of course control won't proceed after, right? If this feels wrong, let's do it something like this. Let answer equal to true. And then if there is ever an exception, you can do answer equal to false. And then return answer. This is simple. Initialize answer to true. Try to run jwt.verify on the token. If it succeeds, then great. If it throws an exception, then the control will reach here. Answer will become false, and then you return answer. Now, if you try to run it with the incorrect value, what gets printed? False. If I send in the right value here, it will work. If I copy this verify JWT function, paste it here, and try to run all the texts npx jest./tests, you will see all of them succeed. The most difficult thing here was verify JWT because you needed to understand this try catch syntax. If you understand this, everything else hopefully straightforward. This is just signing the JWT and using Zod to verify the inputs, email schema, password schema. Verify JWT, the difficult bit, which here we don't worry about the value it returns. I have not even stored it in something. I haven't done const answer equal to whatever because I don't care about this value. The function assignment says return true or false. Assignment doesn't say return username. If it said return username, then I would have done something, but it says return true or false. So I don't care about this value. If this doesn't throw an exception, this true will get returned. If it does throw an exception, answer will become false. False will get returned. And lastly, decode JWT is as simple as calling this. If it does not return null, then you return true. If it returns null, then this condition won't be met, and then you will return false from this function. If you run all of these three, you will have all the tests succeeding. I'm going to push both of these solutions up. So I'm going to copy this whole file, going to paste it here in week 3/solutions, and then o2.js, going to paste this, and then o1 may, I think we had 3 of them, so I'm going to paste these as well, and I'm going to push them to GitHub. So by the time you see this video, you should be able to see all 3 of these. All right. Add solutions, comment -m, added solutions to push that up. All right. So if you're watching this video now, if you go to Yeah, by the time you see it, I'll push it up. By the time you see it, you will see these solutions in a folder called solutions. So if you can actually go there and look at the exact solutions and try to bring them locally. But I would generally urge you that you code them yourself. Cool. That was all for this video. I'll see you guys in the next one. Bye bye.